Last week at the airfield, I was approached by one of the younger students, and he started asking me questions about the aircraft and the aircraft wing. Particularly, how does it fly? And also, he has heard us use different terminology to name certain parts of the wing, and he was curious as to what it all meant. So this week I want to spend a bit of time and just very briefly, not in depth, explain the very basics of the aircraft wing, the terminology, and how it actually works. Okay, the picture you see in front of you is the gentleman that made it all possible, Mr. Daniel Bernoulli, and I will explain to you in just a moment precisely what Mr. Bernoulli said and how that affects us in the aircraft game. So I'm just going to change the setup a bit and then we'll continue from there. Before we get to Mr. Bernoulli and his principles, there are just a very couple of basic terminologies that you should know. For this reason, I've pulled this slide from the NASA Glenn Research Center, and it gives a pretty good indication of the very basic terminologies that you should know surrounding your aircraft wing. If we move to this top picture here, this represents 1/2 of your total wingspan on your aircraft. Now your wingspan is normally from the tip of your wing, of your aircraft wing, to the other tip of your aircraft wing. When we talk of a span, it means 1/2 section of your aircraft wingspan. So you would find the fuselage sitting here with the aircraft wing coming out this side. So if we talk wingspan, you would take in consideration the other side of the wing on the other side of the fuselage as well. The other terminology that you should know about is called the chord. Okay. Now the chord line is a straight line. If we take the cross section of the wing here, it's a straight line from the very frontmost tip of your aerofoil to the very most backwards tip of your aerofoil. Which brings me to the other terminology. The very front of your wing, the part of your wing that breaks the wing first as it flies, is called the leading edge, because it leads the wing into the wind. And the other section, right at the back here, is called the trailing edge. And you would normally find that your control surfaces are situated on the trailing edge of your wing. Okay. The other piece of terminology that you should know is your thickness. Now your thickness of your wing is the thickest part, is measured at the thickest part of your wing. Okay, so as you see the wing goes thicker, on its thickest part you will find the thickness of your wing, and then it goes thinner back in the towards the trailing edge of the wing. Right, let's get back to Mr. Bernoulli and his principles. Okay, what you see in front of you is a typical cross section of a little device called a venturi. Okay, now Mr. Bernoulli said that if air enters a venturi, it would speed up because of the diameter of the area that you push the air through is decreasing, so the air would speed up, and also as it speeds up, the pressure on the air would reduce. Okay, so if you had to push air through here, the bottom of the air would stay constant speed, and the air going into the venturi would actually speed up, and then the pressure inside the venturi would decrease. Now Mr. Bernoulli also said that at the thickest part of your venturi, the pressure will be at the least. Okay, right, now I'm going to show you something. I'm going to take the top part of our venturi away, and what you see now is a very, very basic cross section of a dead standard wing. Okay, so now we take the same principle and we push air in this direction across the wing, and the air flow at the bottom of the wing would stay constant, and the air going on top of the wing would actually speed up as it passes over the top part of the wing. Okay, so what would happen is that the pressure on top of the wing would become lower than the pressure at the bottom of the wing. So in essence, what would happen is that the wing would be sucked upwards. Okay, this is just very basic aerodynamics. Okay, right. For this reason, you'd also always notice that your thickest part of your wing is always in front. No, I wouldn't say always, but mostly in front of the center of your wing. Okay, depends on which type of wing type we talk about. Well, we'll talk about the different wing types in a different video clip. But the thickest part is normally off the center line. Okay, so in the next movie clip that I want to show you now is basically a fluid dynamics study that was done, and while the movie is playing, notice the top of the airflow over the wing section that they've got in the movie clip, and then notice how it exits the wing quicker than the airflow at the bottom of the wing. Okay, so now you've seen that movie clip, and I hope that you noticed that the airflow over the top of the wing exits the wing quicker than the flow at the bottom of the wing. Right, which brings us to the next subject. That same young flyer that came to me and asked me about the wing and how it flies and all the terminology around it, asked me another question. What is a stall? Why does a wing stall? Okay. Right, when you look at a wing, and we go back into very basic aerodynamics, the wind will tend to stick along the surface of the wing. Okay. But say for instance, if this is our wind direction, and we start tilting the wing up, okay, at some point in time, the airflow cannot stick to the wing surface anymore. Okay, so what would happen is the wind would break away from the surface of the wing, and the wing would actually, in effect, stop flying because there is no airflow over the top of the wing anymore. Okay. Right. In the next movie clip, I want to show you precisely what a stall looks like in a wind tunnel. And so with the next movie clip, notice how the wind actually breaks away from the surface of the wing and then causes severe turbulence at the top of the wing, which prevents the wing from flying because there's no airflow to create that difference in pressure. In the next short little movie clip is a camera footage that was taken from a real aircraft, and this is a standard test that they do on new aircraft in real life to just confirm that the wing stalls properly and doesn't create vortexes and uncontrollable and unrecoverable turbulence on top of the wing. So please enjoy this last bit little movie. This was taken by a group in Switzerland doing aircraft tests close to the Alps.
Take